2019 wedge particle question. The wedge has mass 3m, the particle has mass m. Angle is 45, and we have our acceleration directions. Q going that way, and P going down the incline. They want us to write what's happening in separate diagrams. What have we got? 3mg, the weight of the wedge. We have this force R that's going to be coming out of the particle and pushing down on the wedge. We also have another force that we're not going to use, but it's in here. It's pushing down and going up between the surface and the wedge, which is, we'll call it S or R1. And that's enough for that one. We better put our angle in, our 45. Okay, so the particle. We have our 45. Let's put it up the top here. M. We have mg going down. We're going to need these guys adjacent to the angle 45. We're going to have mg cos 45 adjacent. We know that's mg over root 2. And coming parallel to the incline, opposite the angle, is mg sine 45, which is mg over root 2. The acceleration I should have put in here. What do we say it was? Q for the wedge, P for the particle, distinguished down with 2 arrows. We have our R coming out here, and there are all the forces at play. Let's have a quick look at these accelerations that are key to these questions. We have P coming down for the particle, and we have Q going across for the wedge. So that's Q and that's P. If I continue this line up here to create a corresponding angle, because the acceleration of the particle is actually in between here, because we have this force opposing it, the Q going into the right and the P going down to the left. So as this is Q and this direction here is going to be the same as this direction here, so it's going to be our acceleration for these forces. We have a right angle, so opposite is going to be Q sine 45, and here we're going to have Q cos 45. So we know that's Q over root 2, both of them are, and we can write equals Q over root 2 there, just to simplify it now. So that'll give me my acceleration for here, the difference between these two, what's going on here and what's going on here. So it's going to be P minus this one, so P minus Q cos 45, or Q over root 2. We need those force or accelerations when we're setting up our equations. So let's have a look at this wedge. We have R going down this way, but the wedge is actually moving in this direction, so we need to know what's happening going on that way. So that's R. This is going to be adjacent to the angle going down this way, and this is going to be opposite the angle going this way, so it's going to be R sine 45 is the force moving in that direction. Q is the acceleration, and the mass is 3m. So simple enough, R sine 45 is equal to 3mq. So that's the wedge. There'll be two equations for the particle. Let's say going down this hill first. What forces have we got going on that way? Going down, we have this one, and there's nothing else in this direction, no friction involved, so nothing here. So we have mg sine 45, we can change that to mg over root 2. That's the only force, is equal to the mass times the acceleration, which was P minus Q cos 45. P minus Q over root 2. And then we have gone down the hill, so now we're looking at up and down in this direction. And up and down in this direction, we're going to have this one and this one. And we're going to start with mg cos 45. It's going down the hill, it's not going up in the air. So mg over root 2 minus R is equal to m times the acceleration in that direction, which was this guy, which is Q sine 45, or Q over root 2. Okay, we have just got a Q in here. This one just has a Q. This one here has a P and a Q. And this one we can simplify as r over root 2 equals 3mq. So r is equal to 3 root 2 mq. So that makes it look obvious that we're going to use this guy over here to solve for q, and then we'll be able to solve for p. So what have we got? mg over root 2 minus r, which is 3 root 2 mq. 3 root 2 mq equals m times q over root 2. I can definitely cancel my m's here. What am I left with? Multiply by root 2. So we're going to get g minus 3 by root 2 is 3 by 2, which is 6. And that's going to be equal to just q because the root 2's will cancel. So we get g is equal to 7q. So q is equal to g over 7, which divides evenly. 9.8 divided by 7 is 1.4 ms to the minus 2, which is my q. Now, if I bring this guy down, I should be able to solve for p. So I've got my m's can cancel there. Let's get rid of them. So I'm going to get g over root 2. Let's g over root 2 is equal to p minus q over root 2 is equal to p minus 1.4 over root 2. I think the easiest way here is just use numbers and get a calculator. P is equal to 9.8 over root 2 plus 1.4 over root 2. And let's have a look at a calculator. 9.8 divided by root 2 plus 1.4 over root 2 comes out to be about 7.92 ms to the minus 2. That's that question complete. You've got P, you've got Q. It's worth practicing.